All right, this is 2.4b, and we're going to pick up where we left off in the 2.4 notes with completing the square, and specifically completing the square when a is equal to 1. And that a refers to the standard form of the equation of quadratics, which is ax squared plus bx equals c. That's your standard form of the quadratic equation. A is the coefficient of your x squared term. So if that number right there in the equation is 1, then it's going to follow these examples. When we get to 14, we're going to deal with what happens if a is not 1. Right? So let's look at number 11. So the first thing you want to do if you're asked to complete the square is isolate the constant. Now the constant is part C up here in the equation. It's the part without an x on it. So in this example, the -6, I'm going to move that -6 over by adding 6 to both sides. So then I have x squared plus 2x, and I'm going to leave a space, and I'll tell you why, equals 6. Now, our goal is to complete the square and keep it balanced. So the way you're going to know what to do here is you're going to always leave a space when you move the constant over. Take that middle term, that b value right there, and cut it in half. Well, 2 divided by 2 is 1. Take that half and then square it. Well, what's 1 squared? It's a positive 1. Right? So, but what I do over here, I have to do on the right side also. So I'm going to add 1 over here as well. Because now what I have on the left is a perfect squared trinomial, and it is x plus 1 squared, and it equals 7. Now we are back to what we did when we extracted square roots. So we take the square root of both sides. Remember, this is the absolute value of x plus 1 equals the square root of 7. But then we have to split that up, so we say x plus 1 is equal to plus or minus the square root of 7. Now we still want x by itself, so we're going to subtract 1 from both sides. So I will have x equals -1 plus or minus the square root of 7. And there's my two solutions using completing the square. All right, let's try this again with number 12. First step again, move the constant over. So I'm going to add 1 this time, so x squared minus 4x. Leave a space, equals positive 1. Now, again, what's the deal? Take the b value, cut it in half. So -4 divided by 2 is -2. And then I square it, and I get a positive 4. So I'm going to add 4 on the left. That means I got to add 4 on the right. So this is going to equal 5. Now let's think about this. What does this factor down to? Well, this would be x minus 2. Square. Now, how do you know which sign goes where? Well, take the sign from the middle term, the negative, and take half of what you had right here in the middle, which was a 4 divided by 2 gave us 2. Same thing happened over here. We took the sign of the middle term and half of its value. So now I have x minus 2 squared equals 5, and now it's extracting square roots again. So I'm going to take the square root of both sides. Remember, that's absolute value of x minus 2 equals plus or minus the square root of 5. Well, extract it. So I have x minus 2 equals plus or minus square root of 5. Add 2 to both sides. So I have x equals 2 plus or minus the square root of 5. There's my two solutions. All right, let's try 13. Same deal again. Move that 8 over. So I'll have x squared minus 4x. Leave a space, equals -8. Now I'm going to take that middle term, cut it in half. So -4 divided by 2 is -2. -2 squared is positive 4. So I'm going to add 4 here, and I'm going to add 4 here. Then this is a perfect square, and I need to figure out what it is. Well, x, and see the middle term is negative, so I'm going to bring the negative down. What's half of 4? It gives me 2. It's all about that middle term. -8 plus 4 gives me -4. Now we're back to extracting square roots again, so square root it. So this is the absolute value of x minus 2 equals the square root of -4. So that's x minus 2 equals positive or negative. Now, we know 4 is a perfect square. That's the same as -1 times 4, right? I is a perfect square. We can take an I out, and 4 is a perfect square. Okay. Now I can move my -2 over. So this becomes x equals 2 plus or minus 2 square roots of I. and we've completed our square. All right, so hopefully that gives you an idea of how to complete your square. We can talk more about this in class if we didn't get it as fast as I did it. So let's talk about what happens when it's not equal to 1. Well, you're still going to start with the same step. Move that constant over. So we're going to have 2x squared minus 4x, leave a space, equals negative 1. Now look over here. What can we factor out of these two guys right here? We can factor out a 2. We don't want to factor the x and the x squared and the x out. Let's leave that be. So then we have x squared minus 2x equals negative 1. Now, here we go. Again, take your b term, cut it in half. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1, right? So I'm going to add 1 right here. Now, don't just add 1 on the right because we have this extra out here. So it's just 1 times 2 gives me 2. So now we have this. We have 2 times, what is this now? It's a squared factor. Again, take the middle term and cut it in half. So it's negative 1 that we've squared equals negative 1 plus 2 is positive 1. So before we extract square roots, we're going to divide both sides by 2. So I have x minus 1 squared equals 1/2. Then I extract my square root. I'm going to scoot over here so I have a little more room. So I have x minus 1. Absolute value of x minus 1 equals the square root of 1/2. Okay? Alright, so this means I need to x minus 1, make the plus or minus square root of 1/2 right there. Okay? Then add 1 to both sides. So x is equal to 1 plus or minus the square root of 1/2. And there are my two solutions. Okay? So we just factored out the 2 and that we added a step right here. Okay? That's all we had to do when that a value is not 1. Now, solve by quadratic formula. All right, you've heard of quadratic formula from Algebra 2. If you've not memorized it, please memorize it. You will be required to know it. So a and b and all that stuff goes back to the standard form of a quadratic. So it's ax squared plus bx plus c equals 0. So the numbers a, b, and c come right from your equation. All right. So obviously, like on 15, I need to move that 8 back over so I have the 3 values on one side of the equal sign. So doing that, I have x squared plus 3x plus 8 equals 0. Now I can use the quadratic formula. It says negative b, so negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times 8, which is c. Okay. I'm just going to clean the numerator up really quick before I do the denominator. Plus or minus, this will be 9 minus 32. So negative 3 plus or minus the square root of negative 23. Remember, that's negative 1 times 23. Negative 1 is a perfect square, so I can make this negative 3 plus or minus I square roots of 23 divided by 2a, which was 2 times 1, which is just 2. So there's my answers. Remember, the plus or minus contains both answers. That's a positive and a negative. Okay? All right, let's try 16. This one's already in standard form, so I can just jump right into the formula. So negative b would make that 20 plus or minus 20 squared minus 4 times a times c. I'm going to put that on the bottom. 2 times 20 is near the bottom. So let's clean this up. We have 20 plus or minus 20 squared is 400. 4 times 5 times 20 is 400 over 40. So that's 0. So really all I have is 20 over 40, which is 1/2. So x is equal to 1/2, and it's a double root. All right, easy enough. Look at 17. All right, on 17, it's definitely not in standard form, so I need to put it in standard form. I tend to put everything on the left, especially I want to make my x squared term positive. So if I move both of these over, they're going to switch signs. So this is going to be x squared plus 4x minus 8 equals 0. Then I use quadratic formula with a, b, and c. So negative 4 plus or minus b squared, which is 16, minus 4 times a times c. This is 16 plus 32 all over 2a, which was just 2. All right, so negative 4 plus or minus, that's 48 over 2. All right, so let's simplify square root of 48. That factors down to 16 times 3. Well, that's a perfect square. So negative 4 plus or minus 4 square roots of 3 over 2. Now, before you start crossing stuff out, you can factor a 2 out of each of these. And I have negative 2 plus or minus 2 square roots of 3 over 2. Then you can cancel them. So my x value will be negative 2 plus or minus 2 square roots of 3. Okay, so that got rid of our fraction. All right, let's look at 18. Already in standard form, so we're going to just jump into quadratic formula. So this will be negative 16, negative b, plus or minus, square root, b squared, so 16 squared is 256, minus 4 times a, which is 4, times c, which is 17. So if I put that in my calculator, I get 256 minus 4 times 4 times 17, which all of that is 272. So if I subtract them, I get negative 16 in here. Divided by 2a, well, 2 times 4 is 8. All right, so now I need to simplify my radical. Negative 16 is a negative 1 times 16, both of which are perfect squares now. So I have 16 plus or minus 4i over 8. All right, so I can do some reduction here. I'm going to reduce everything by 4. So I'm going to take a 4 out, and I'll have a negative 4 left, plus or minus I over 8. Those two will reduce with the 2 on the bottom. So negative 4 plus or minus I over 2. And those are my two solutions right there. All right, hopefully this jogs your memory on completing the square and using quadratic formula. We'll talk in class more about this, so let me know what questions you have.